Alright, welcome back. We're on ACT Prep Unit 6, Plane Geometry, Day 8. We're going to talk about circles today. Alright, a circle is all the points a set distance from a fixed point called the center. There's your center. Every single point on this circle is exactly the same distance away from that center dot. The diagram below shows a circle along with its center. A radius is this line. The diameter goes through the center. And yeah. So the diameter is a line segment, meaning it ends, that passes through the center and has endpoints on the circle. A radius is a line segment with the center for one point and the endpoint on the circle. The circle is named by its center, so this would be called circle O. Alright, so chords, secants, and tangents. A chord is a line segment with endpoints on the circle, so it can be anywhere. There's a chord, there's a chord, there's a chord. Alright, as long as it has endpoints on the circle and it's contained inside the circle, then you have a chord. Okay? Your secant is a line. Line means it goes on forever and ever and ever, that contains a chord. So it has to have in other words, it has to pass through the circle, but the line keeps going forever and ever and ever. Whereas a chord doesn't. It has endpoints on the circle. The secant keeps going. A tangent line is a line that touches exactly one point right there. It looks like it touches a bunch of points, but it doesn't. It only touches that point right there. It touches exactly one point on the circle. And what's neat about a tangent line to a circle is it's always perpendicular to the radius at that point of tangency, touching. Okay? Angles, arcs and angles. An arc is any portion of the circle. So this, see how they put this little curved thing over it? That says arc, SU, and it's talking about this length right here. Okay? A central angle is an angle formed by two radii. In other words, their vertex has to be at the center of the circle. So angle STU would be a central angle. And we say that angle STU intercepts arc SU. Because see how if you kept it going, it intersects the circle, which creates that arc SU. An inscribed angle is an angle formed by two chords. So whereas a central angle has to be formed by two radii, in other words, it has to have its center, its center at the, its angle at the center of the circle. An inscribed angle, the angle can be anywhere, just formed by two chords. So with the vertex on the circle somewhere. So if I look at angle PQR, that angle right there is an inscribed angle. And the angle PQR intercepts the arc. In other words, the arc created by that inscribed angle would be PR. Now, there's neat relationships between angle measures and arc measures. So we know that the total number of degrees in a circle is 360 degrees. Okay? If you have the measure of a central angle, like this one, that measure of that central angle is always the same as the intercepted arc. So since arc SU is 70 degrees, I know that angle T is also 70 degrees. Okay? What's cool about inscribed angles and their arcs is that the measure of an inscribed angle, so whatever this angle is, this would be angle Q, would have to be half of the intercepted arc. So my angle Q would be half of 90 degrees, which means angle Q is 45 degrees. Pretty cool? Cool. Alright, so you try this one, hit pause, come back when you're ready. And hopefully you got 90. So it says in the figure below, the measure of arc AB, that's this distance around, is 180. What is the measure of the inscribed angle theta? Well, this is the angle that intercepts this arc. And by definition, theta is half of arc AB. So my theta is going to be half of 180, which is 90 degrees. Okay? All right, try this one. Hit pause. Come back when you're ready. And hopefully you got 60 degrees. So in the circle below with center O, what is the measure of arc BD? That would be this one. Well, this arc is going to be the same as this angle. They have to be equal because that's a central angle. Well, if you look, this, let me get a different color. This line right here is 180 degrees. Well, if here to here is 120, 180 take away 120 leaves 60 degrees over here, which makes this arc 60 degrees because they're equal. All right, so let's do some practicing here. It says, what is a diameter? Well, definition says it's a line. I'm going to shorthand it a little bit. It's a line through the center with endpoints on the circle. I'm just going to use a circle with a dot in it to show circle. What is a radius? It's not a line. Oh, this is a line segment, sorry, because it stops. This is a line segment also. Forgive my handwriting. Oh my goodness. It's a line segment with an endpoint at center and the other end point on the circle. 3. In the diagram below, identify the center, the radius, and the diameter. The center is C. A radius would be CB or CA or CD. I see 3 radiuses there. And my diameter is the one that goes all the way across, which would be line segment AB. Cool beans? All right, 4 says, what is a chord? A chord is a line segment with endpoints on the circle. Okay, what is a secant? A secant is a line, not a line segment, that contains a chord. And 6, what is tangent to a circle? And it's a line, not a line segment, that touches circle exactly once and is perpendicular to its radius at that point. Okay, so 7 says in the diagram below, identify a chord. A chord is a line segment, so it can have arrows on the end. So that would be line segment CD. A secant is a line that goes forever and ever and ever, but it contains a chord, so it's got to pass through the circle at some point. So that would be line BX or XB. And a tangent, that's outside the circle, but it only touches it once, and that would be line EF is tangent. And if you drew a radius to that point, it's perpendicular. Okay? Okay, so questions 10 and 11. I'm sorry, I don't really know what happened to 8 and 9. Somewhere they got lost. 10 says, identify the central angle and the inscribed angle. Well, your central angle has to have its vertex at the center. So my central angle would be angle STU, and my inscribed angle is the one that isn't at the center, which would be this one, which would be angle PQR. 11 says, what arcs are intercepted by this inscribed angle and central angle? The arc intercepted by the inscribed angle would be arc PR. The central angle, the arc intercepted by the central angle would be arc SU. Okay? All right, for 12 and 13, refer to this diagram. It says, what is the measure of arc PQ? Well, that's a central angle which is equal to the arc measure. So if the central angle is 50, then the arc is 50 degrees. Okay, they want me to find the arc length of RS. Well, the theorem or the formula says that your angle measure is half of the arc measure. So my angle, which is 30 degrees, is half of my arc, which is RS. To get RS alone, I'm going to multiply by 2, and so I get arc RS is equal to 60 degrees. Yeah? Okay, 14 and 15. What is the measure of arc AB? That's from a central angle, which are equal, so that's 40 degrees. CD, well, it says the angle, the inscribed angle, is half of arc CD. Well, I know the angle is 68, so I have 68 equals half of arc CD. So to get arc CD alone, I'm going to multiply by 2, and I get arc CD is equal to 136 degrees. Okay? For 16 and 17, we have this information. We know that RP is 120, and we know that RS, which is all the way around to here, is 180. So first they want the measure of angle theta. Theta is a central angle that intercepts this arc, so it's equal, which is 120 degrees. And then they want the measure of alpha. Well, here's alpha, which is this arc, yes. So it says that angle is going to be half of the arc, which is 180. So my angle alpha is going to be 90 degrees. Okay? Alright, so we've got another figure here. Alright, they want us to know what is the measure of theta. Theta is a central angle that intercepts this arc. They're equal, so that's 72 degrees. For alpha, again, it's a central angle, so it's equal to its arc intercept, which is 35 degrees. And then they want beta, which is going to be half of arc RMS. And then, you know, when you got this big arc with everything in between, they like to give 3 letters to say you're passing through that. Okay? So my angle beta is going to be 1/2 of, and they said all the way from R to S is 230 degrees. So it's going to be half of 230, which makes beta equal to 115 degrees. Okay? Alright, this next one's a little weird. It says the circumference E, or circle E, has a circumference of 6 units. And it gives you the measures of DEF is 80 degrees, CEF is 55, and ABD is 60. So it says, what is the shortest distance around the circle from point A to point D? So they want this, okay? Well, what they want you to do, first of all, you got to figure out that arc length. So my angle is half of that arc, which makes times 2 times 2, it makes arc AD 120 degrees. Well, I got to figure out how much of the circumference 120 degrees is. So I need to figure out 120 divided by 360 is 1/3 of the circumference, which was 6 units. So I've got to figure out 1/3 of 6. Of means multiply. That's 6/3, which is 2 units. So this point A to point D is 2 units long. Okay, from point D to point F, we're doing this. Okay, I'm going to come up here, D to F. Well, that's a central angle. So we've got angle DEF is 80 degrees, which is going to be, that's going to be my arc DF is 80 degrees because it's equal to the central angle. So I need to know 80 degrees of 360. Well, that comes out to, reduces down to 2/9, which reduces down, doesn't reduce. So I want 2/9 of the 6 units, which gives me 12/9, which gives me 4/3, which gives me 1 1/3 units. So this distance is 1 1/3 units of the circle. And then from B to C, from point B to point C, let me erase this because now we're going from here to here. Okay, oh crap, I erased that. That was 55. Right, and D, E, F was 80. So we know that this is 180 degrees because it's a straight line, it's a diameter. So to get what's left, if I take off 80, that's going to leave 100 degrees, right? So for here. So I want from here to here, which is 155. So my arc BC is 155 degrees divided by 360 gives me 31/72 of my 6 units. That gives me 186/72, which gives me 2 7/12 units. So that's where they got the 2 7/12 from. Okay? All right, try this one. Hit pause. Come back when you're ready. Come on. There we go. All right, which of the figures below shows a chord? The chord has to go through the circle but have endpoints on the circle. That would be this. That's tangent. That's a central angle. That's a secant. And that's an inscribed angle. Okay, try this one. Hit pause. Come back when you're ready. And hopefully you got G. Which of the figures below shows an inscribed angle? Inscribed means it doesn't have a vertex at the center, but it's got to be an angle. Well, these are all lines, and that's a central angle. Okay, try this one. Hit pause. Come back when you're ready. And hopefully you got 84. They want to know the arc measure of RS. Well, that's a central angle, so these are equal. So that's got to be 84. Try this one. Hit pause. Come back when you're ready. $270. All right, in the figure below, arc AB measures 180, given. And both theta and alpha intercept this arc. What is the sum of theta and alpha? Well, alpha is a central angle. I don't draw my alphas very well. So alpha has to be 180 degrees. Theta has to be half of its intercepted arc. So theta is half of 180, which is 90. So if you add those together, alpha plus theta is 180 plus 90, which is 270 degrees. Okay, try this one. Hit pause. Come back when you're ready. Okay, so it says in the figure below, the measure of arc AC is equal to twice the measure of BC. So since BC is 90, then AC is 180, which I could tell because that's a straight line anyway. So what is the length of segment AC in triangle ABC? Well, here's the problem. They want the length. They don't want degrees. Well, I know that in this, if this is 90, okay, then the arc that the angle, oh, I can't talk, I'm sorry. Angle A has to be half of its intercepted arc, so it's going to be half of 90 degrees, which makes angle A 45 degrees. Okay, so if that's 45 degrees, and look, this arc is 180, so it's intercepted, so angle B is half of its intercepted arc. So angle B has to be 90 degrees, which gives me a 45-45 right triangle. And if you remember from our 45-45-90 right triangle, whatever the leg is, the hypotenuse is the leg square roots of 2. Well, this says the leg is 2. And remember, in a 45-45-90, legs are equal. So my hypotenuse has to be that length times the square root of 2. Okay? And that does it for day 8. I will see you next time for day 9.